Hello guys, welcome back to Smart Engineering Academy. Myself Amit. So let me continue with the MCQs on influence line diagram. I'm just taking this question, just add up the thing what I'm writing here. In the question they're asking ILD for shear force at 2 meter from left support. Is it fine? So I'm just, this is the question which is given here. I'm just writing the question here in order to make you a clear understanding. Let me take this as a 2 meter and the remaining length is 6 meters. Point A, point B and point C. Okay. They're asking us to write a shear force at a 2 meter from the left support. From the left support, this is the point where 2 meter is present. That is nothing but indirectly they're telling find the shear force at a point C. At this point you need to find the shear force. For that I would like to draw an influence line diagram with respect to shear force at a point C. The influence line diagram will come like this. So at a point C, this ordinate will be this distance 2 divided by total length which is 8, and here the ordinate will be this 6 divided by whole length is again 8. Fine. So this is 3 divided by 4, 2 3s are 2 4s are 2 1s are 2 4s are 8. So this is the influence line diagram with respect to this thing. And if I can go through this, see here. So this drawing is correct, but when coming into the ordinate, see this is 3 by 4, of course this is 1 by 4. So option A is right. But when coming into the option B, the drawing, influence line drawing is correct, but the ordinates given here is ulta. It became ulta. So this is wrong. Of course, this is very wrong. This is right for reaction at a point A. If in the question, if they are asking reaction at a point A, then this is right. Then this will be right. If I take this point as C, this point as A and this point as B, this will be the influence line diagram for bending moment at a point C, but the ordinate changes AB divided by A plus B, just neglect it. This is right for reaction at A, and for this question, this option will be the right answer. Is it fine? This is how my concept, what I had explained in the previous lecture series, will work out in the MCQs. Please go through those concepts before coming into the MCQs. Let me move on to the next question. A very important question. Fine. Let me read out the question. For a simply supported beam of span 10 meters, simply supported beam they have given, the span of the simply supported beam is how much? It is 10 meters. Influence line diagram drawn for a bending moment at a section 4 meter from the left support. Okay, from the left support there is a point which is 4 meter and the remaining distance will become 6 meter. At this point, let me take this as a point A, B, and let me take this as a C. So they are asking from the left of the 4 meter left of the section, the maximum bending moment at a section due to the moving point load of 160 kilonewton. There is a moving point load of 160 kilonewton which is moving from point A to point B, so that we need to calculate the maximum bending moment at a point C. How to do that? I am just writing the section like this here. And let me take this as a point C. From this point, it is 4 meter. So everything I am writing with respect to the question which is given here, the total is 10 meters. And one point load which is present, which is 160 kilonewton, which is moving from a point A to point B, that is from left to right, or either take it from right to left. But we need to calculate the maximum bending moment when this 160 kilonewton load is going to reach at the point C. So the influence line diagram will come like this. So at a point C, you draw a ordinate. The ordinate distance will be AB divided by A plus B, you know, which is 4 into 6 divided by 10. It comes to be 2.4 will be the ordinate distance. And I am placing 160 kilonewton load at this point. So what is the maximum bending moment? Maximum bending moment formula is equal to load into ordinate distance load is 160 kilonewton into the ordinate distance is 2.4, so you'll get it as 384 kilonewton meter. So option C is the right answer for this question. Whatever the structure they will give, either they will ask reaction, you should know how to draw the reaction for with respect to influence line diagram. Either they will ask shear force, either they will ask bending moment. That is one thing. Second thing, they may either give point load means load into ordinate distance. If they give uniformly distributed load, for uniformly distributed load, I have already given you the chart in my lecture series. Please make use of the chart for the placement of load on the particular point on the beam. Fine. Let me move on to the next question. See, this was the question which was asked in Public Works Department examination, which was conducted on 2020. What is the shape of the influence line diagram for a maximum bending moment in respect to the simply supported beam? With respect to simply supported beam, the maximum bending moment shape of the influence line diagram will be parabolic. Okay, repeated question in Public Works Department examination. Fine. Let me move on to the next question. Muller-Breslau principle in a structure is analysis used for, see, whatever the influence line diagram we are drawing, it is mainly with respect to Muller-Breslau principle. On Muller-Breslau principle, I had explained you many things. It is used to draw the influence diagram for determinate structure as well as indeterminate structure. But for determinate structure, it will be, the influence line diagram will be straight. For indeterminate structure, it will be parabolic. Let me move on to the next question. Muller-Breslau principle is applicable to get the influence. I had not answered the question. I'm very sorry. Muller-Breslau principle, it is analysis of drawing influence line diagram for any force function. Writing virtual work method, no. It will come in some other. Superposition, no. For drawing the influence line diagram for any force function, you are supposed to use the Muller-Breslau principle. Muller-Breslau principle is applicable to get influence line for which one of the following? It is mainly used to find the influence line diagram for reaction at the end of the simply supported beam. Not only reaction, not only bending moment, not only shear force, forces and moment of at any section. Okay, fine. Let me move on to the next question. This is very important question. Okay. See, this kind of question I had solved in the lecture series. Select the correct influence line diagram for a shear force at X. For this, let me write down the structure here. This is a point X and it is a overhanging position. For this, I need to draw the influence line diagram with respect to these positions. So, if I want to write the shear force at a point X, I need to draw the shear force. So, how the shear force will come? See, here it comes like this. If I take this distance as A, in the question, okay, fine, they have given 6 meters, no issues. If this is 6 meters, they have given this as 12 meters, right? And this is 4 meters. If this is 6 and this will also be 6. And the influence line diagram here, it will come like this. And it will come like this. You can write like this also. You can also make it like this. This will also be correct. So option B will be the right answer. Whatever the notation you follow that thing. Fine, let me move on to the next question. Okay. This is very important. Write the influence line diagram at a support B. What will be the influence line diagram? Same question I had solved in the lecture series. Here there is a hinge and this is the roller support B. If I want to write the influence line diagram, which is very important, since there is an internal hinge present here, it simply comes like this. The reaction, they are asking us to find the reaction at a support B. At a support B, I am putting 1 unit load, 1 unit rotation. So it will be like this. So option B will be the right answer for this question. Yes. This is very important question. influence line diagram for a reaction B. At a reaction B, we need to draw the influence line diagram as shown in the figure. Okay, so what I am going to do, I am just writing the structure here. Point A, point B, this is the internal hinge present here. Point C, internal hinge is present here. Let me take this as E, F. Let me take this as D. Okay, I need to draw the influence line diagram for this. What is the type of influence line diagram that I need to draw? That is nothing but a point at a reaction at point B. Reaction at a point B. That means at a point B, what I am going to do, I am applying 1 unit rotation. Is it fine? On the left side, what happens? It ends like this. But since there is a internal hinge present here, the moment will be acting like this because influence line diagram is coming like this. So it comes like this up to point C. Later, since there is an influence line diagram here, yes, it comes to be like, and up at a point D, it ends here. But since there is a overhanging portion here, it comes like this and it ends like this. Writing influence line diagram comes by practice. Take more number of numerical problems because there is no substitution part here. The only analysis of the mind is very important. Okay, here internal roller, the pressure will act in this direction, but in case here pressure will act in this direction, so that it will be balanced. You need to make a balanced equation such that if one internal hinge is acting upon the topmost side, it has to be act in the bottom side. If this also acts in the topmost side, again influence line diagram will become like this, so it should not be that case. Fine, let me move on to the next question. What is the ordinate of influence line at B for the reaction at D shown in the given figure? I am going to write it here. And this is the point C where internal hinge is present here. Let me take this as A, B, C, D. Is it fine? So let me make use of this unit itself. They are asking us to find the reaction at a point D. In order to find the reaction at a point D, I need to find the influence line diagram. Draw the influence line diagram for reaction at a point D. If you want to write the reaction, you need to install 1 unit rotation at a point D. Later what happens, since there is a C is present here, it comes like this. In case if there was no internal hinge present at a point B, only this was the case. But since there is an internal hinge present here, the moment will act upon like this because influence line diagram is coming like this. So it comes to like this. Is it fine? So at this point, what is this distance? 2 meters. This distance is again 2 meters and this distance is 4 meters. I know 1 unit rotation is present here. By making use of the similar triangle concept, I am going to take the ordinate. See, this is straight. This is straight, okay? So how to do, how to make the use of similar triangle concept for 4 meters. For 4 meters, what is the ordinate which is given here? It is 1. Okay, for this 4 meters. For this 2 meters, from this point, take it this point as a B, this point is a base. From base point to this here, it is 4 meters, it is 1 unit ordinate. From base point to here, it is 2 meters. What is the ordinate distance? Let me take it as x. So making use of cross multiplication, 4x is equal to 2x is equal to 1 by 2, which is equal to 0.5. 0.5 will be the ordinate distance for this thing. And in the question they are asking, what is the ordinate of influence line diagram at a point B? At a point B, the ordinate is 0.5. So answer is 0.5. This is how they may ask, either if the load is given, they either may ask the bending moment, shear force, ordinate. You should be get ready for all the things. Is it fine? So we'll do one more question. Which one of the following is correct in respect of the influence line for a bending moment? Okay, for a bending moment at 1/4 of the span from the left support of a prismatic beam simply supported at the ends. That means they're telling simply supported at the end beam. We need to draw the influence line diagram for 1/4 of the section. Let me take this, the total length is L. This is 1/4 of the section L. Let me take this as A. And the remaining distance is B. That is the remaining distance. I'm just taking this as A and this as B. If I draw the influence line diagram with respect to bending moment at a point C, it comes to be like this, and the ordinate distance will be A into B divided by A plus B. Okay, let me read out the options. It is composed of straight line only. Okay, it is composed of curved line only. It is composed of straight as well as curved lines, and it is a parabolic. See in the question, see in the thing, it is straight line. It is present, the present thing is straight line only, and it is in the shape of triangle. Shape is triangle. It is composed of straight line only. This is also the question may be asked in this way. So that's all for the session, guys. So the remaining questions we'll study in the next upcoming lecture series. Thank you and all. Bye bye. Take care. See, any queries, please do comment me in the comment section. So I'm taking 4 more classes to finish off this influence line diagram. I'm making maximum MCQs on influence line diagram. Please join my Telegram group, which is given in the description column. Thank you and all. Bye bye. Take care.